Well, good morning, everybody, from Springfield, Massachusetts. That's where I am today. And what's interesting is the cloud cover that's over the top of us today is all a part of that same system that has ripped across the United States over the last 24 hours. And it's been a fast mover. Soaking wet in parts of the Northeast today, but this, of course, is following a pretty incredible event that happened yesterday. So I want to take you back to some satellite data just to see this thing really progress across the country. Now, we'll have to wait later in the week to do a full analysis on how much snow came out of this, but we had snow from the plains stretching all the way down here to the Denver, Colorado area. I mean, big time snows coming in through this part of the Front Range of the Rockies. And then it just absolutely massive turnover in temperatures in the midsection of the country. But of course, there was a lot of severe weather last night that mainly was focused around this part of the Midwest. And we have to go again and look at some of the wildfires that were down here in Texas. You can see their heat signature on the infrared as the sun was setting last night. Now we're about to go into a reset mode. All of this is going to start off again in the Pacific Northwest with the next system that's going to roll through. And as you're going to see in a few moments, I don't anticipate March slowing down through the first half in terms of the jet stream pattern that we're in right now. So let's get into this. I want to take you to Texas first and just show you last night. It's pretty amazing satellite imagery here. You can see this frontal boundary sliding to the south. You can see the cumuliform clouds that are popping up on it. All of the cloud you see here is very high in the atmosphere. This is all represented cloud cover where the subtropical jet stream lives. And as we watch, you can see the advancement of that frontal boundary. And what it's hard to see under here, maybe some of you can see better than I can, but there's smoke. We had very strong winds out of the west for a while, blowing the smoke from these huge fires down in this part of the Texas Panhandle, mainly blowing them from west to east. But when the front crosses right here, right around sunset, there you go, that's going to shift the winds to be coming out of the north. You can actually see the heat signature of these fires showing that north-south orientation of the wind. So again, just an incredible frontal boundary sliding over the top of those fires, redirecting them, making them considerably worse as the sun sets. So this is now, we're working on day 3 of watching wildfires throughout the central plains of the United States. I think these have been some of the most prolific in putting a lot of towns in danger down here in parts of Texas. Outside of that, I want to take you to the Midwest and just want to watch the radar animation over the last, half day or so. And as we just reset this back to last night, here it goes, about to start over again. This is all snow on the back side of this. And look at the snow that was in here in parts of Colorado. But I mean, it stretched all through this area after hitting the northern plains in northern Minnesota yesterday. Now, early this morning, we still have tornado watches out to about 8 o'clock this morning in parts of Kentucky, 1 till 10 o'clock in parts of Ohio. But one of the bigger storms that we had to pay close attention to last night erupted right around the Quad Cities initially. There it is. And then rolled right across Chicago. I was kind of hoping to be able to stick around and see some of this, but my flight took off on time, and I was over into Boston while all of that was happening last night. And unfortunately, couldn't even get a view backwards to see if I could see any of the towering cumulus clouds with that setup. But this was a potent and very fast-moving system, and I need us to understand why I've been stressing so much about the speed of this system compared to the ones following it, and we're going to do that again in a few moments. But just to show you that storm, watch this blow up right here, rip across Chicago. In fact, let's pause that. I want to show you something neat that often happens over the lake. So this started off as individual storm cells. Because of the wind shear, they merged into one larger system here, basically where the anvil of one storm produces rain that falls into the next, and they become one large system that rolls through. And then you can even see it developed a pretty potent, what we call bookend vortex on the northern edge of this squall line here. And as it comes ripping through, it ended up becoming a bow echo across Lake Michigan. Lower frictional values over the water probably helped that. And then these storms continued into lower Michigan while the main frontal boundary comes sliding in behind it. Now, I don't often show video from Twitter or pictures from Twitter because I always wait to get permission from folks to do that. And sometimes I record too early before anybody responds. So I'm just going to tell you something. You can go to my Twitter page. My Twitter handle is Snodgrs, Snodgrss. And that Twitter handle, if you're curious why I took the A out of my last name, that's actually because that's what the University of Illinois did. I was a student there, did my graduate work there, and then also I was on faculty there for 13, 14 years. And I think as a nod to 8-bit computing, they keep all of their what we call net IDs to 8 characters. And so they took the A out of my last name, so I've just adopted it. I'm Snodgrs, okay? But if you want to come here and scroll through I liked a lot of stuff from last night if you didn't get a good chance to see it. So I just want to let you know that that's one way by which you can see what some of this stuff looked like. Okay, when it was all said and done, let's blow this up a bit here. Here's storm reports through this morning. Now, this is going to change throughout the rest of the morning as more of these come in, but I got 11 tornadoes, 114 reports in total. We kind of watched that one area and through here, and then a secondary region down here in the Ohio Valley that blew up the storms last night. Okay, hail. Let's just take a quick look here at some of the hail reports. Not hail reports, excuse me. This is radar observed hail. Where we had it last night, and there was probably quite a bit of damage done by some of this hail, some very large hail, 2-inch hailstones coming into parts of northern Illinois. You know, we don't have some of the big staple crops that are grown here, of course, planted yet, so not a lot of crop damage, but this is going to do a lot of damage to, to other parts of the infrastructure for farming, and also houses and cars. So just something to think about here. So where are the storms this morning? Well, I was just tracking them a bit with some lightning data here. We can kind of see the active storms moving through Ohio, parts of West Virginia into Pennsylvania, but then that frontal boundary stretching into parts of Kentucky and western Tennessee. So quite a bit of active lightning early this morning as these storms continue to press toward the north and east. The frontal boundary with this, remember how we talked about these major swings in temperatures? Well, compared to yesterday morning, we have some places that are between 30 and a couple of locations, like right here, that are approaching 50 degrees in terms of a temperature change just in the last 24 hours. Now, we know that these temperatures are going to rebound very quickly by the end of this week into the weekend, but this was a pretty sharp frontal boundary. And I've often talked about these frontal boundaries and what they mean in terms of something called the thermal wind. And I just want to show you something neat here. So this is where the frontal boundary is about the time I'm recording, around 6 a.m. this morning, a little before. And that frontal boundary has got these strong winds out of the northwest behind it, delivering all that colder air. Now, what I want to show you is, if you see the boundary here, so the warmth on one side, the cold on the other, that boundary in temperatures is amplified as you go up in the atmosphere. And we call that the thermal wind relationship, where there's a lot of warm air here and cold air on the northern side. And what it does is, over the warm air, the atmosphere has a greater upward extent. It's expanded and it's contracted on the colder side, and the slope of that height is what drives the winds. It's actually a slope in the height field is equivalent to a slope in the pressure field, and you end up getting winds in this area that are really absolutely screaming. Now, I was interested if there were any flights in this morning, and I went and found one that left Cancun 5 hours late. So here it is. And what's interesting is the trajectory that it's taking to get to its destination, which is Toronto, Canada. So flew straight north and then tried to get into these winds, I think, to make up some time. And I'm sure that it did. For a while there, its speed, if you come down here, jumped all the way up. Look at this speed. Their speed jumped all the way up here to nearly 700 miles an hour with a planned speed of only 550. So amazing just to see that. But they're on descent now to land, and so that's why the speeds are down. I just love to look at this. These flights that get stuck in this. Now, the next story is here. This is our second wave that comes in. Here's a subtropical jet, and these are going to be additive once again. It's going to hit the northwest, Northern California first. This system, okay, remember earlier I said the speed of one system versus the speed of another. This system's going to be slower, and I want to show you what the difference in the speed is going to mean. Now, remember, there is the bigger branch to the north, but there's also going to be a weaker low that sneaks out on the southern side of this first. So we just need to kind of walk through all of that and what it means. So as of about 5:20 this morning, we had high wind advisories. This was still the tornado watch, which is set to expire at 8 o'clock this morning. This one at 10 o'clock. Flood watch is out in places, but a lot of wind chill on the northern side. Here's the break. Now we go back to the west. Winter storm warnings, blizzard warnings, high wind warnings. This next system that's coming through is going to pack a pretty serious punch. Now, I do want to show you, this was snowfall through 7 o'clock last night, Eastern Time, 6 p.m. Central. Now, remember, a lot of snow fell after this, but this part of the Red River Valley of the North, which just picked up 6 to 10 inches of snow in places, this has been one of the biggest snow events of the season so far in that area, given how we've missed out on so much snow in this area. So we're going to ask that question, will this upcoming pattern continue to deliver more late season snow to this section of the country? But I mention again stuff about the speed because I really want you to look at this graphic pretty carefully. Through 5 a.m. this morning, this is total accumulated precipitation. And when these systems move fast, they don't have the time to curl up and occlude. And as a result, the precipitation streaks across the country and doesn't deliver a good drink to everyone. And that's really a major concern for much of the country right now, given the drier conditions we've seen in February. Now, this is a soil moisture map, which is just to highlight the point I made. And I want you to remember that I normally show you the 0 to 100 centimeter soil moisture. So that goes down 40 inches. This is the 0 to 10. This goes down 4 inches. And this is to make the point of how dry things have been in parts of the Midwest, in the South, in the Southeast, as of late, as these systems have missed this area throughout the month of February. Now, the good news is the West is loading up with deep troughs. We've been talking about that now for a long time, and that is going to start to increase the chance of opening the Gulf of Mexico and delivering good March moisture to some very dry areas, in addition to hitting the West repeatedly with huge mountain snows, probably pretty heavy valley rains, and also incredibly strong winds. So let's go have a look at all of this, okay? Let's start you off here about 8 o'clock this morning. This is the high-res NAM. 3 systems to watch. 1 exit, 1 forming. The third one is our next big March storm system that's coming into the Pacific Northwest. So it's kind of our pencil-thin band of convection rolling through this part of the country. It then spreads into New England. So I'll be dealing with this all the way until later tonight. I'll be very curious. I'm supposed to fly from Boston to Charlotte to Chicago. So we'll have to see if I actually get home tonight. I really hope I do. But if you hear me recording in the morning in an airport, that's what happened. Okay, behind this, a quick changeover to snow, lake effect happening, but that front's going to clear with some speed. I mean, it's really moving fast. Now behind this, okay, we got the lake effect snow here, but watch the system coming out of New Mexico. As it gets into parts of northern Texas, there is the chance of adding some snow. We've got plenty of cold air that's going to be in place early tomorrow morning for that to use. That's all going to change quickly, but right now that's what we've got. Now this system kind of falls apart a bit right here because remember, we're waiting on this high to start to open up the Gulf to its southern side and bring in the moisture. So the moisture from this one really begins to show up as we get toward the Mississippi River Valley. So this is now 4 a.m. on Friday, just so you know where we are in time. And I wouldn't be surprised if we get a little bit of snow that sneaks through parts of Texas and Oklahoma, maybe clipping Arkansas, Kansas, and up into Missouri. Watch this again right here. Right in through there. Now, to be honest, that's really nothing compared to what we've got going on in the West, where there is a blizzard warning out for the Sierra Nevada and winter storm warnings for the Cascades. So can I take you back and let's focus on the West to get some timing here? This is midday today on Wednesday. We can see the frontal boundary from the deeper low that's up near British Columbia ripping through. Snow levels are going to drop all day long as we get into Thursday midday, Thursday afternoon, and that front swipes through and clears through parts of Idaho, Montana, stretches all the way down here. So you've got the effect of altitude or elevation and a frontal boundary, which is why we're worried about strong winds and we're worried about some pretty impressive snowfall rates. So that is just through Friday. That would be the beginning of spring, March 1st. That's the beginning of meteorological spring in the Northern Hemisphere. And then after this, we're still watching a loaded Pacific jet. When I say loaded, this is what I'm talking about. As we play through Wednesday, getting into Thursday, here's a little shortwave sneaking underneath. Here's the deeper trough. That is what's loaded right now. So as we play this through Friday, getting into Saturday and Sunday, the fact that that trough keeps dipping over the west while the ridge occupies the east is the setup that just tends to drive the most active weather in North America. That's where you've got southwest flow coming out of the desert southwest rolling like this. It opens the Gulf, drives deep cold air into the west, and what we do is by Sunday into Monday of next week, we just continue to see low pressure systems pinwheeling around this broader trough over the west. So this is all the way up to March 7th, March 8th, and that's going to be one to watch right there by March 9th. So I kind of tried to give you numbers for these systems. I don't know. There's several. That's all I'm going to say. Several of them coming through over the next 10 to 15 days. And even by the middle of the month, and we're going to talk about this again at the end of this video, I continue to see the jet stream wanting to live in some sort of configuration like that. And what that means is if we keep the troughs in this particular configuration, what's supporting it? Is it the MJO? Is it El Nino? We're going to show you that here in just a few moments, all right? Okay, so now that you've seen that I'm watching deeper troughs in the west continue to pull through, what does it mean for our timing of the next few systems? The skill scores in the GFS made a nice jump last night. They came back up and they're closer to what the European model says. But let's just kind of keep an eye on both models here as we play through the next 10 days. So remember, these are operational runs, which means we trust them about 5 days out, and beyond that, we're just using them to get an idea. So we're already 30 hours into the simulation, which is, let's get into Thursday morning. This is Thursday midday into Thursday evening. Big front comes in northwest. Rain starts to go through the Mississippi Valley, possibly some storms in there. By Friday, that's putting a pretty big soaker over parts of the southeast. So this is midday Friday. Watch the snow just push into the west. Both models hammering this area with heavy snow by the time we get into early Saturday morning. And then that low as it emerges. Remember, the jet has got a negative tilt on it. The trough does. So this low comes out and rolls north, and that slows the whole thing down. So that's snow for Montana. That's snow for parts of Alberta, Saskatchewan, Manitoba. That's ice possibly right in through this area on Saturday into Sunday. And that low rips through, drags another front right in through this part of the Midwest, and then it moves on off to the east. So if you just watch, can you just keep your eye right here for me? This is Friday morning, Saturday morning, Sunday morning, Monday morning. See that? And then there's another trough right behind it, right here. Now the issue with this one is, because it is making this hard turn, how is it going to be able to dump a lot of rain in some places where we desperately need it? I'm talking about the midsection of the United States. It won't be able to. It's going to take a system that curls up down here over Colorado and New Mexico to make that happen. And we're starting to see evidence of that. Once we get out there to the 6th, 7th, 8th, and 9th, there's going to be another big system that rolls out into that area, 6th, 7th, 8th, and 9th, that has the potential for finally loading up the midsection of the country with some good moisture. Now, some of you that have heard me speak this fall, I've said many times, or not fall, this winter and early spring, I've talked about wanting a big storm system like this one. I'd like a little bit farther to the south if you let me wish cast, and I want more snow into this area before we get into the month of April. So this kind of pattern can be conducive to something like that, but I just want to let you know that even through the next 10 days, the pattern is quite loaded to bring in quite a bit of snow north and rain and storms to the south. So let's play it all forward and see what this gives us from the high-res European model. We're going to park it out there at 1 week, which is 168 hours, and this is what we get. So I've got moisture for the south and southeast, moisture for the east coast. I've got it for parts of the Canadian prairie, given that low that's going to curl up like this in the west is getting absolutely hit hard with this. But our donut hole still sits right here in the midsection of the country. Again, first system too fast, second system curls to the north. We've got to get another low to come out in this area and slowly traverse the country. And that may be what happens after this. This is what the GFS says over the next 7 days. European, GFS, and as you know, I like to compare them both. So when you look at this map, these are the colors where the GFS is wetter than the European. This is where the European is wetter than the GFS. So just take a look at your area and you can see which model shows up differently. Okay, by the way, did you know you can also go here, go to agweather.com, and you can type in your location. I live outside of Champaign, Illinois, so I start typing. That's code number 273. When you click on this and you see your forecast, you can actually compare the models. 10-day ECMWF versus GFS versus NBM. So there's all the models. You can just kind of see the timing of when they're putting in precipitation and look at the differences. Boy, the NBM is a dry model right now. Okay, let's get back to the snow side of this. Adding up that snow through the weekend, getting out there into early next week. It is important to note here that in the Sierra Nevada, almost the whole of the mountains that roll along the west coast, we're off the top here. So there's the potential for 4 to 6 feet of snow. We're talking about 2 to 3 feet in the Northern Rockies. And as you know, this is exactly what I wanted to see in the West as we kind of punch our way into this, into the spring time frame. We needed this good push of snow to finish things up, to load those mountains up with snow. Once this is done, we'll look at the snow basin numbers. It's no point looking at them now. We'll have to see what happens when they change. But that is the ECMWF, and here is the GFS. Now remember, the GFS drags this front through with that last system, which is why you see the snow here, not really well resolved in the European. But you can see the lighter snow coming in later this week right into this area as well in the European. Okay, we always do this where we go straight to the probability maps. This is, I think, where the story is really told. I say that every time because there's so much uncertainty beyond day 4 or 5 that the ensembles give us a clue as to where the strongest signals are in the atmosphere. So you've been looking at a map that goes over the next 10 days, probability of an inch. Here's the probability of 3 inches of snow. Look at this, we need this bad. Here's the chance of 6. A lot of good moisture trying to return to the very dry parts of the Canadian prairie, getting over into, this part of Hudson Bay and Ontario. Now, when we start to get into these serious amounts, there's the chance of 12, 18, 24, 36, 48. I love doing that just to see how big the snows could be in the Cascades in Sierra Nevada. On the drier side of this, look at what has shrunk. This is the area that now over the next 10 days has a probability of staying under 1/10 of an inch. Now, you know that all week long we've seen this being much brighter, right? But that final system, that one that comes in, the 6th, 7th, 8th, and 9th, it's a slower one. It's farther to the south, and that's why things are looking better here. Now, on the wetter side of this is the probability of getting an inch over the next 10 days. And here we go up to 2 inches. So look at the southeast, up the east coast. Look at the west coast, where the probability of getting 4 inches is quite high here. So again, that is more symptomatic what this pattern is doing than anything, which is a return, I think, to a more substantial subtropical jet. So by the 9th through the 10th, we do see, here's our polar jet. It's coming through. There is a trough in this area, but the subtropical jet right in through here is our strongest piece to this. And that's one of the big reasons why the week 2 forecasts tend to be wetter across the south. Okay, you can see that with a little bit drier signal farther to the north, getting back to the northwest. If we do get a resurgence of the subtropical jet, that is what we'll end up getting. Now, before we get into the longer range, let's talk about the temperatures quickly. This was about 540 this morning, where you can see just how cold the air is behind this. So we have, -7 up in Fargo. This is some really cold air that's coming in behind this. It's short-lived, but it is a sharp cold front that's rolling through. Frost potential, I just wanted to mention the Central Valley of California is now going to be flirting with another frost event as we play through the next 7 days. This isn't uncommon for most of the other areas shaded, but right in there we have to keep a close eye this time of year. On the max temperature side of things, here's today's highs, but watch the transition. Ready? This is max temperatures today. Thursday, my goodness. So we have places this morning in the northern plains that are in the negative single digits. And then by Thursday, I'm seeing the temperatures going back up into the mid-upper 50s. What a massive swing. There's Friday, getting into Saturday. There's Sunday. So remember, this is when that low came in like this and rolls straight up here along that temperature gradient. So very mild east, very cold west. And then you go back into Monday. So what a swing in temperatures in the northern plains this week. That's just incredible to see. And there's next Tuesday. Now, if we look at the overall pattern, this is day 5 through 10. Still quite mild east, cold throughout the entirety of the western part of North America. And day 10 through 15. What we continue to watch for is anything that can poke this pattern in a different direction, unlocking some cold air across the north and delivering it to the south. It's not yet showing up in the GFS, nor is it showing up in the European. That's day 10 through 15. That's day 5 through 10 in the European. This is day 10 through 15 in the European. So I'm not yet seeing something that can deliver extremely cold air for several days in a row across the south. And that's one of the things we're on the lookout for. Okay, let's transition this into a bit of a longer range discussion. I've shown you this a dozen times. I'm going to stick to it. This is the March outlook using every El Nino year that's been in transition. And we continue to see a pattern that is not only showing up in the analogs, but also showing up in the models. This is the newest March outlook released yesterday from the European model on precipitation anomalies. Looks very similar overall to this picture, doesn't it? Very similar overall to that picture. And then if we switch over to the temperature side of it, we've got this. Now yesterday, I made a case to say that there's the chance that toward the end of March, let's watch it again, toward the end of March, we see some colder signals showing up here. And I want to know if that's true, right? I told you we're going to be investigating this. So here's something to think about. The MJO has made this jump out over here into phases 3, 4, and is expected to get into 5. And I said if it keeps sweeping around, then the chance of redistributing cold air across North America increases. But I also made the case to say, well, what if this actually collapses back into null space and just lives in this area? And I want to bring you to some really important research about the MJO. Now, when I talk about this, I just want you to remember that this is phase 3, 4, this is roughly where these are, 5, 6, 7, and 8. Okay, so let's just go ahead for completeness, 1 and 2. Sorry for my handwriting here. I'm just drawing this on my computer's, the trackpad. Okay, so we know that when we have such warm ocean temperatures in the Indian Ocean, and we get into this time of year where the El Nino begins to fade. Now, what is an El Nino? El Ninos occur where you get really strong westerly wind bursts. That's really what they are. They're westerly wind bursts in the trade winds, which normally flow from the east to the west. When these go away, we have a difficult time getting the MJO to leave this area and then run back out to phases 6, 7, and 8. Now, what does all that mean? That means that the MJO doesn't like to do this whenever we have an El Nino that's fading, which makes me wonder if it's going to come up here and then collapse and do this again. Now, what's the point in telling you that? Well, if I'm concerned about this late March cooler weather getting over here into the southeast, which means it's got to come through the rest of the country, I would need to see a major change in the MJO for that to happen, because I don't think it's coming from the polar vortex. I certainly don't think it's coming from any sort of North Atlantic or North Pacific disruption at this point. I think it has to do with the tropical connection with El Nino fading and what the MJO does on top of it. So I like to look at that several different ways, and here's one way. Now, if you follow the blue-greens on this diagram, they're going to kind of give you a representation of where the best upper level motion is in the atmosphere, rising motion, sinking, rising. And you notice that it's starting out here. We just kind of line this up, phase 2 and 3, and it's moving through 4 and 5 and moving over towards 6. Now, a complete progression of this would just have it keep moving in this direction, and I'm curious if it's got this a bit off. And the reason for that comes down to this map here. Okay, so what are we looking at? This is today, and this is going through the next couple of weeks. And do you see these blue-greens? Those represent, okay, not westerly wind bursts, but stronger easterly winds. Now, when I look at that, I go, well, if we have stronger easterly winds over the next several 10 to 15 days, that would place the convergence coming from the westerlies, which are shown here, somewhere back in this vicinity, not making the progression over to phase 8 and then a reset over to phase 1. And we're starting to see that even in the evidence of where that upper level rising motion is. So take note that day 10 through 15, the best rising motion staying here. It didn't pop out over there. Now, again, we look at all of that to just try to assess where the MJO, which is ultimately the reason why we look at it is it's ultimately the key in understanding how heat and momentum are transferred out of the tropics into the extratropics to crank up the jet stream and change its position. And if this doesn't move way over here, then I don't have a reason to say it's going to be any different than it is now. That's my point. If it just keeps living in this area, what is there to change everything else? Now, we did lose the really cold air that's been over parts of Russia, Mongolia, and China. But I still think that we're going to get an active Pacific jet that favors troughing in the west for a while into March. And I'm basing that off of the fact that the MJO will likely not progress over into the Pacific Ocean. So what does that mean? It means the biggest convection is likely going to stay here. And we can already see the models responding. Look at parts of Australia, Western Australia, getting into South Australia, the Northern Territory, very, very wet. This is uncharacteristic of a late summer, early autumn pattern in this area. What else is happening? This will likely keep Western Europe wet, Eastern Europe dry. This will likely keep the wetter conditions over Pakistan present. And it will finally probably keep this area over drier. Not dry, but drier. Wetter Argentina, wetter in this section of Brazil, but drier in the center west. That will be key to watch with this pattern. So I just want to put out a thought. I have to continue to test the thought, right? I mean, we're going to do that. But this is just one of the things that I've learned over time. Okay, that's it. I'll talk to you again tomorrow. Thanks.